Today I would be talking about important aspects of obturation of the root canals. See, we all know that in the root canal treatment that we do, starting from the excess cavity preparations to the cleaning and shaping, obturation is one of the last steps, and it is the most critical step which affects the prognosis of the root canal treatment. Okay, if the root canal is not three-dimensionally obturated, if we are not creating a fluid tight seal, previously the concept of hermetic seal was in prevalence. By hermetic seal, it was meant an airtight seal. But the contemporary endodontic practice does not support the concept of hermetic seal. Whenever we obturate the root canal three-dimensionally, what we actually strive to achieve is a fluid tight seal so that there is no to and fro passage of fluid through the root canal. Means the root canal should be a fluid tight chamber after obturation, and it should not allow any passage of fluid either from the oral cavity to the periapical tissues or vice versa. So this obturation basically involves use of two things. One is the core material that we use, and another is the sealer around the core material that we use. These core materials that are used for the obturation can be of further two types. They can be solid core materials or they can be semi-solid core materials. Solid and semi-solid core materials. An example of a solid core material that has been used are silver cones or silver points, we can say. Silver cones or silver points. Then we have got resin cones. Example is Resilon. These are customized cones made up of methyl methacrylate resin, and they are called Resilon. They are stiff. Both silver points and resin cones are stiff. They are classified as solid materials. On the other hand, if we talk about semi-solid materials, okay, the semi-solid material that is most frequently used are gatta parcha. The gatta parcha cones we use. These gatta parcha cones that we use for the obturation of the root canals, they are basically trans isomer of 1,4-polyisoprene. They are trans isomer of 1,4-polyisoprene. It is a product of the trees of the Sapodilla family. So just like natural rubber latex, we obtain this gatta parcha from the trees, and chemically it is trans isomer of 1,4-polyisoprene. So the form that is obtained directly from the trees is the alpha form of gatta parcha, and the processed form of gatta parcha that is used is the beta form of gatta parcha. So principally there are two forms of gatta parcha, the alpha and the beta form. The beta form is the one that is commercially available as gatta parcha points or cones. So these gatta parcha points, which are semi-solid core materials that are available for the obturation, they consist of, if we talk about the composition, 65% zinc oxide. Principal ingredient is zinc oxide in them. 20% they consist of gatta parcha. What is gatta parcha? I have already told you. And we all know that gatta parcha are visible on the radiographs. That is, they are radio opaque. To make them radio opaque, 10% of barium sulfate is added. And to make them flexible and pliable so that they are easily introduced into the root canals, we add 5% waxes and resins. This is composition of typical gatta parcha cone that is available in the market. So you have to remember that it is the beta form of gatta parcha that is used, and the composition consists of principal semi-solid materials that are used. These gatta parcha cones, they have a manufacturing tolerance plus minus 0.05 to plus minus 0.07 millimeters. What is manufacturing tolerance? I have told you in the previous session when I discussed about cleaning and shaping. And so this manufacturing tolerance is in the range of 0.05 to 0.07 millimeters. This much the size variation in one particular gatta cone is allowed. If we talk about the solid core materials, it was in the year 1931 that Jasper, Jasper, introduced silver points. These silver points were introduced by Jasper in the year 1931. These silver points, they had the advantage in the sense they were easily introduced in thin and curved canals. Okay. Another advantage of these silver is they conform to canal anatomy in apical one third. The most crucial part of the root canal is the apical one third. So they conform to the canal anatomy in the apical one third, but they do not adapt very well into the middle and the coronal one third of the root canals. If we talk about the disadvantage, definitely silver corrodes in the oral cavity. Okay, whenever it comes into contact with the tissue fluids, there is corrosion of the silver points, and these corrosion products they can induce periapical infection or periodontitis and non-healing lesions. That's why the silver cones in the contemporary endodontics, they are not recommended. They are no longer used. They are no longer considered to be the standard of care for obturating the root canals. So the principal semi-solid materials that we use as a core for obturation of the root canal are the gatta cones that are available in the market. If we talk about the sealers that are used for the obturation, they are covered by ADA specification number 57, and there are certain requirements sealer. What are the requirements of materials to be used as sealer? Firstly, the flow of the sealer, that is measured as the distribution of the sealer on the wall of the root canal, should be greater than 20 millimeters. If we talk about the solubility of the sealer, it should be less than 3% by weight. It should be stable in the oral cavity. It should not be soluble, and if at all it is soluble, it should be less than 3% by weight. The requirements for sealer according to ADA specification number 57. Then radio opacity. Each and every material that is used should be radio opaque, should be greater than 3 millimeters of aluminium. Then we talk about the film thickness of the sealers. They should be having low film thickness so that they spread easily onto the walls of the root canal, maximum coverage of the surface area and filling of the voids between the wall of the root canal and the core material is there. It should be less than 50 microns. And finally, we talk about dimensional stability. These are the requirements for your sealers. According to ADA specification number 57, it should be in the range of plus 0.1% to minus 1%. Okay. Plus 0.1 to minus 1%. This means it should not expand or contract beyond this limit. These are the 5 standard requirements to be met for sealers. These sealers, they can be various type of sealers like ZOE based sealers, calcium hydroxide based sealers, resin based sealers, GIC based sealers, okay, paraformaldehyde based sealers. Paraformaldehyde based sealers. They can be calcium silicate based sealers. Okay. And they can be silicon based sealers. Silicon based sealers. So, based upon the principal ingredient, these are the various categories of sealers that are available in the market. If we talk about these sealers, then common examples of ZOE based sealers can be Crossman sealer, Tubely seal, okay, calcium hydroxide based sealers, Apexit, and White Apex. I'm giving you common examples of the brand names that are available of the respective sealer category. Resin based sealers, AH26, AH plus, Endorase. Okay. GIC based sealers, Kipec, Endo. Paraformaldehyde containing sealers, they are not recommended in the contemporary endodontic practice. Means we should refrain from using any sealer that contains or releases paraformaldehyde because it is a known cytotoxic agent, and in excess cases it can even contribute to some amount of carcinogenicity. But if you have to remember for academic reasons certain examples, the examples are Riebler's paste and N2, that is also called Sargenti. Calcium silicate based sealers are one of the contemporary sealers available. Example are MTA Filapex, MTA Plus. Calcium silicate, they are MTA like sealers. And silicon based sealers, example are Rocoseal and Guttaflow. So these are the various categories of sealers and their predominant examples. And all of these examples of sealers, all of these category of sealers should follow the basic requirements as outlined under ADS specification number 57 for endodontic sealers. Okay. Now we talk about various methods or techniques of obturation. Methods of obturation of the root canal. The first and the most common method that is used is cold lateral compaction. Cold lateral compaction of gutta percha inside the root canals. And for lateral compaction of gutta percha, the instrument that is used is a spreader. What is a spreader? See, spreader is basically an ISO normed instrument. ISO normed means it would follow the same specifications and color coding as given for other instruments according to ISO. But it is a smooth and tapered instrument with a pointed tip. A smooth tapered instrument with a pointed tip is a spreader, and this is the instrument that we use for cold lateral compaction. So there are two principal steps for before doing this cold lateral compaction. The first one is master cone selection. Master cone selection. Before going with the obturation, we have to select a master cone. This master cone is the principal cone that should seat to the full working length. This master cone, it should seat to full working length. And this fit of the master cone is verified radiographically. We will expose a radiograph to verify whether the master cone is fitting properly or not, and that is commonly called master cone radiograph before the obturation. Okay. So, if this is the root canal that has been prepared, then this master cone, it should fit snugly to the full working length. And there should be resistance to pulling it above, which is called tug back. Okay. When we try to pull the master cone up from the root canal, there should be slight resistance that is felt. It should not be too loose. Okay. There should be some resistance to coronal displacement that is called clinical tug back. That is the confirmation of retention form. There should be retention form in the master cone. Sometimes there is a radiographic phenomena called wiggly appearance of master cone. When you took a master cone radiograph, what you notice that the master cone appears wiggly. What is wiggly appearance? Means the master cone would appear twisted. It is a gatta parcha cones. We know that they are what? They are plastic flexible materials, isn't it? So when you took a radiograph, you saw that there's a wiggly appearance of master cone on the radiograph, and the reason for this wiggly appearance is obstruction in the canal. Obstruction in the canal. And because of that obstruction, the master cone is wiggled or appearing twisted in the radiograph. Another thing about the master cone fit is that it should be dried in a wet canal. Means before selecting a master cone, the canal should not be dried, because if we dry the canal, there would be friction in the root canal and improper master cone selection would be there. We would be doing obturation of the root canal after coating the root canal with sealer always. So sealer acts as a lubricant. So similar situation we have to create while having a master cone selection. That's why we select a master cone in a wet canal. The second step before proceeding for the obturation is spreader selection. With regard to spreader, two things we have to talk about: the size of the spreader and the taper of the spreader. We have seen that they are the ISO normed instrument. They follow the same specifications as ISO. Size of the spreader should be such that it should be fitting 1 to 2 millimeter short of working length. WL stands for working length. We have to select a spreader that is slightly larger in size as compared to your master cone. Your master cone is sitting to the full working length, but your spreader should be 1 to 2 millimeter short of working length. Because the purpose is that the apical millimeters, 2 or 3 millimeter of the root canal should be obturated only with the master cone. There should be no lateral space around the master cone in the most apical part of the root canal. And if your spreader is penetrating up to the working length, it would displace the master cone, and this would create a space around the master cone in the most apical portion of the root canal. To prevent that, we would select a spreader whose size is such that it is 1 to 2 millimeters short of the working length, and taper of the instrument should be equal to the canal taper that we have prepared. What is meant by canal taper? See, whatever file we have used for preparation of the root canal can have a standard 2% taper or other tapers like 4, 6, 8% taper. Similarly, the instrument that we select, the spreader that we select, its taper should match with the canal taper. If it is 2%, then the 2% canal taper should be there. If 4% canal taper is there, then the spreader should also be 4% taper. Why? Because if we choose a spreader whose taper is less than canal taper, means a 4% canal taper is there and you have chosen a spreader 2%, then it would seep or penetrate more as compared to the designated 1 to 2 millimeter short of working length. And because of this, what would happen? The master cone would be displaced. The master cone would be displaced coronally. So there would be loss of retention. Okay. On the other hand, if we choose a spreader whose taper is greater than canal taper. Okay. Means a larger taper, it would create a wedging force inside the root canal. When we put the spreader, there would be a wedging force inside the root canal. Then the master cone, it would be displaced apically. There would be loss of resistance. So to prevent the loss of retention, that is coronal displacement, and loss of resistance, that is apical displacement, we have to choose a spreader whose taper matches with the canal taper. Once we have selected the proper master cone and the spreader, what we do, this is the root canal. It is the walls of the root canal. They are coated with sealer. Coating of the sealer or placement of the sealer. The placement of the sealer can be done with various things like master cone itself. It can be done with a file. It can be done with lentulospiral. Lentulospiral is a spring-like instrument like this. Special instrument for coating the walls of the root canal with sealer, or we can use ultrasonic compaction. The master cone can be used, the file can be used, lentulospiral or ultrasonic compaction. Out of the various methods used for sealer application, ultrasonic compaction, it results in most surface coverage. Maximum distribution of the sealer onto the walls of the root canal happens with ultrasonic compaction of the sealer inside the root canals. Okay. But 100% sealer coverage never occurs with any of the method. Maximum coverage of the sealer that we can get on the walls of the root canal is in the range of 60 to 70%. Okay. But the best coverage is with ultrasonic compaction of the sealer inside the root canal. Okay. Another important thing is that method of obturation. Whatever method of obturation we use does not influence sealer distribution on apical 1/3 of root canal. Irrespective of the method, the sealer distribution remains same in the apical 1/3 of the root canal, but the method of obturation, whatever method we choose, does has an influence on sealer penetration into dentinal tubules. What are dentinal tubules? They are tubules in the wall of the root canal. Okay. Sealer penetration in the dentinal tubules. So there are two things: sealer penetration and sealer distribution. Sealer distribution is the surface coverage. Sealer penetration is the depth of insertion of sealer inside the wall of the root canal. The method of obturation has no influence on the distribution of sealer on the walls of the root canal in the apical 1/3 of the root canal, but it influences the sealer penetration into the walls of the root canal. Okay. Then what is done? This is the canal that has been coated with sealer. Okay. The master cone of gutta percha is taken. It should see to the full working length. Okay. In the next step, the spreader that has been selected is inserted alongside the master cone to create space. It is left in place for 10 to 15 seconds so that sufficient compaction of the gutta percha cone occurs. It is removed, and after removing it, an accessory cone of gutta percha is inserted. Like this, we keep on inserting the gutta percha cones laterally around the master cone. This is known as cold lateral compaction. And the master cone is the one that would see to the full working length. If we talk about the advantage of this method, it is relatively simple. method of obturation. If we talk about another advantage, it has got good length control, which is an important aspect of obturation. The obturation should ideally be to the full working length, neither short nor long. So good length control is provided with cold lateral compaction. On the other hand, if we talk about the disadvantages of this method, there are chances of voids between multiple GP cones. No matter how do we do compaction, there are always some microscopic spaces left around. Okay, so these are the and inadequate sealing of lateral or accessory canals. The primary root canal would be sealed properly, but the lateral and accessory canals, they would not be sealed properly. These are the disadvantages, principal advantages and disadvantages of cold lateral compaction method of obturation. Second method of obturation is warm vertical compaction. Warm vertical compaction. As the name indicates, warm vertical, we would be heating the gutta percha inside the root canal. And this technique was first given by Shielder. It is also called Shielder's technique of obturation, warm vertical compaction. And the instrument that we would be using is a plugger. Spreader for cold lateral compaction, plugger for warm vertical compaction. This plugger is also an ISO normed instrument that is smooth and tapered, but with a flat tip. It has got the same color coding as with other hand instruments, as with spreaders. The only difference is the spreader is pointed, the plugger is flat tipped. Then if we talk about master cone selection or placement, the master cone should be selected so that it is 0.5 to 2 millimeter short of working length. This is an important consideration for warm vertical compaction. The master cone should not reach the working length. It should be 0.5 to 2 millimeter short of the working length. So what is done? This is the root canal that has been prepared for the obturation. We select a master cone that fits short of the working length by 0.5 to 2 millimeter. A suitable plugger that has been selected is heated and vertical force, apical force is applied with the heated plugger. How can we heat the plugger? If it is a manual plugger, it can be heated on a clean alcohol flame till it is red in color. More specifically, cherry red in color. It is red hot. Carry it alongside the master cone and apical pressure is applied. The heat of the plugger would melt the gutta percha and it flows apically and laterally, so it seals the lateral and accessory canals. And that is the reason, because the gutta percha is melting and flowing apically and laterally, we keep it short of the working length. If we talk about advantage of this technique, then definitely there's better sealing of the lateral and accessory canals. There's better sealing of lateral and accessory canals, which is not there with cold lateral compaction. If we talk about the disadvantage, no matter we are keeping it short of the working length by 0.5 to 2 millimeter, and once we are placing a heated plugger and applying apical pressure, we are expecting the gutta percha would melt and flow to the exact working length. And that is an empirical thing. There is no method to ensure that when we are applying pressure with a heated plugger inside the root canal, whether the gutta percha is adequately melting and flowing up to the working length or remaining short or going beyond the apical constriction. So most principal disadvantage is poor length control. because these are heat softened gutta perchas. And another potential disadvantage is occurrence of vertical root fracture. Why vertical root fracture? Because pluggers, they act like wedge inside the root canal, and when a apical pressure is applied with a plugger, it can cause lateral forces onto the wall of the root that can develop a vertical root fracture. So chances, potential of vertical root fracture is one of the disadvantage. The third method that can be used for the obturation of the root canals is thermomechanical compaction. Thermomechanical compaction. What is thermomechanical? As the name indicates, thermo, heat, and we are generating heat and softening the gutta percha by way of mechanical energy. So we would be using some instrument to generate heat inside the root canal that would soften and flow the gutta percha. The device is max Spadin compactor. That device is max Spadin compactor. This max Spadin compactor is a rotary instrument with design like a H file but in reverse. Okay, this is a design of a reverse H file configuration, the blade design or the flute design. If you remember, an H file on the other hand looks something like this. This is an H file and this is a max Spadin compactor. So this is a mechanical instrument, a rotary instrument that would generate mechanical heat to soften the gutta percha inside the root canal. What is done? This is the prepared root canal. Then we select a master cone that is slightly short of the working length. And it is an important fundamental thing that you can remember whenever we are using some form of heat, the gutta percha should be ideally slightly short of the working length so that it does not flow beyond the apical constriction or the apical stop that we have created. Okay. So it is short of working length by nearly 1 to 2 millimeters. In the next step, what is done? The max Spadin compactor is placed alongside the master cone and it is rotated at 20,000 RPM. Okay. At a low to medium speed, it is rotated 20,000 RPM. So because of the rotation inside the closed confines of the root canal, mechanical energy converts into heat energy that softens the gutta percha. It flows apically and laterally to seal the canal up to the working length. This is thermomechanical compaction and the device used is max Spadin compactor. Other example of devices are micro seal system. Micro seal system, right? That is used. Micro seal system. They are basically nickel titanium devices. Micro seal system, they are nickel titanium devices. Then another method of obturation would be chemically plasticized gutta percha. Chemically plasticized, as the name indicates, we are softening the gutta percha by certain chemicals. The chemicals that can be commonly used are chloroform. Chloroform can be used. We can use halothane, which is also a general anesthetic. We can use xylene, a hydrocarbon compound. We can use turpentine and we can use eucalyptol. oil of eucalyptus. These are the prominent chemicals that can soften the gutta percha and help in flowing and obturating the root canals. Chloroform is one of the best methods or best chemicals for softening the gutta percha inside the root canals. And this technique was first given in the year 1921 by Callahan and Johnston. Chemically plasticized gutta percha technique. Okay. What is done? The master cone is selected, which is usually up to the working length. We are not applying any heat or pressure, so we select a master cone that is up to the working length only. Okay. This is the root canal. Then this is the master cone that has been selected. Only the tip of master cone. It is dipped in solvent. Whatever solvent we have chosen, only the tip of the master cone is dipped in solvent, not the entire master cone, but only the tip of master cone. And this is usually done for 1 to 2 seconds only. That is enough to soften the gutta percha master cone. The root canal has already been coated with sealer. There is no exception to this, that always the root canal would be coated with sealer, no matter what technique of obturation we are using. And this master cone is then placed to the working length. So this slightly softened apical 1/3 of the gutta percha would seal the apical part of the root canal better as compared to a cold gutta percha. This is your chemically plasticized gutta percha technique. Then we have carrier based gutta percha techniques. Carrier based gutta percha obturation. Carrier based, as the name indicates, there is a central carrier on which gutta percha is coated. So there would be a central carrier. On this central carrier, there is a coating of gutta percha. This configuration is called carrier based gutta percha. This technique of obturation was first given by Johnson. The use of carrier based gutta percha. This central carrier, it can be made up of either metal or it can be made up of plastic. Metal again can be either stainless steel or it can be titanium. Central carrier, when made up of plastic, usually two types of plastics are used: liquid crystal plastic and polysulfone polymer. What I'm telling you, these carrier-based gutta perchas can be made up of a central carrier that can be either a metal or a plastic. Plastics are available in two different categories: liquid crystal plastics and polysulfone polymers. These polysulfone polymers are advantageous as compared to liquid crystal plastic in that they dissolve in the gutta percha solvents. See, when no matter what method of obturation we are using, we should always leave a possibility for a future retreatment of the root canals in case there is a secondary infection or reinfection of the root canal. So the possibility of retreatment should always be there. And that possibility is there even when we are using a plastic polysulfone polymer, because just like gutta percha, they can be removed from the root canal with the help of one of the solvents, the chemicals that we have seen already. Another important property of these carrier-based gutta percha is that this gutta percha is alpha phase of gutta percha, unlike the beta phase that we use for other techniques. This alpha phase is the unmodified natural form of gutta percha that is more pecky or sticky. as compared to beta phase of gut aperture. Okay, it also undergoes less shrinkage upon setting as compared to your beta phase of gut aperture. These are the two important technical differences, and the carrier is coated with alpha phase of gut aperture. Examples of the techniques commercially available devices that use carrier-based gut aperture are Thermafill, Successfill, Simplyfill. Okay. These are the common examples: Thermafill, Successfill, Simplyfill. The Simplyfill is basically something like this. There's a metal shaft onto which a gut aperture 5 millimeter is attached. Simplyfill. Okay. This is mostly used with light speed instruments. When I talked about the generation of nickel titanium instruments, you must be remembering that the first generation of nickel titanium instruments involve instruments like light speed, profile, and GT files, isn't it? So, light speed instruments, we are preparing the root canal with them, and we can obturate the root canal with what? Simplyfill, which is a type of carrier based gut aperture system. Another contemporary example is Gatta core, carrier based gut aperture. Gatta core. This Gatta core is different in the sense it has a central carrier that is made up of highly cross-linked Gatta aperture only. No metal or plastic is used, but it's a highly cross-linked and condensed form of Gatta aperture that is used, onto which the regular alpha phase of Gatta aperture is coated. This is known as Gatta core. So this is a different type of carrier-based Gatta aperture system. Then we have thermoplastic injection techniques. Thermoplastic injection techniques. Up till now, we have been using either a cold form of Gatta aperture or we have been softening the Gatta aperture by applying some form of heat or mechanical energy or chemical solvents. In thermoplastic injection techniques, there is injection of liquid aperture inside the root canal. Direct injection of liquid Gatta aperture inside the root canal system. Okay. A common example is a high heat technique. A high heat technique of thermoplastic injection of Gatta aperture that is commercially available as Obtura system. Obtura. Okay. This Obtura system basically consists of a gun-like device with various gauges of silver needles. There are silver needles available in various gauges. According to the diameter of the root canal, we can select gauge of the needle according to the diameter of the prepared root canal. There is a Gatta aperture cartridge that is inserted into this electrically or battery operated device, and it heats the Gatta aperture in the range of 160 to 200 degrees Celsius. Okay, that's why it is called high heat technique. We know that the melting point of Gatta aperture is somewhere around 65 degrees Celsius. When it is heated to high temperatures of nearly 160 to 200 degrees Celsius, it melts, and when we press the trigger, the liquid Gatta aperture comes out and it fills the root canal. This is thermoplastic high heat injection technique. This liquid Gatta aperture has a temperature somewhere around 72 to 75 degrees Celsius. which is fairly tolerant with the adjacent hard and soft tissues of the oral cavity. Another method is low heat technique. Low heat technique. The low heat technique commercial example is ultrafill. Ultrafill. This ultrafill device consists of a electrical heater. Okay. This heater heats the gatta parcha to 90 degrees Celsius. That's why it is called low heat technique. But what is the melting point of gatta parcha? 65 degrees Celsius. So 90 degrees Celsius also is hot enough to liquefy the gatta parcha. It consists of stainless steel needles and gatta parcha cannulas. Ultrafill system. Other prominent examples of variable heat techniques are calamus, hot shot, and elements. What are these examples? These all are examples of the commercial products available for thermoplastic injection of gatta parcha inside the root canals. So whatever method we choose for thermoplastic injection, what would be the advantage? It is very much obvious now that whenever we are injecting liquid gatta parcha or we are softening the gatta parcha inside the root canal, it flows apically and laterally better as compared to solid form of gatta parcha. So there is better apical sealing of lateral and accessory canals. Isn't it? But what is the potential disadvantage? It is quite obvious by now that poor length control. We cannot control how much of the gatta parcha would flow exactly and to what depth it would flow. Okay, we always expect it to flow up to the full working length, but most of the time it either remains slightly short or flows beyond the apical constriction or the prepared apical stop. So poor length control is a principal disadvantage of thermoplastic injection techniques. So these techniques, they are better suited for backfilling of root canals. The backfilling of root canals. What is meant by backfilling of root canals? Suppose this is a prepared root canal, then the apical portion of the root canal is obturated with solid gatta parcha, like cold lateral compaction method or any other thing, and the coronal and the middle one third of the root canal we obturate with thermoplastic gatta parcha. This allows for good length control and better sealing of the coronal and the middle one third of the root canal. This is known as backfilling of the root canals. Injection of thermoplasticized gatta parcha into the coronal and middle one third after obturating the apical one third with a semi-solid form of gatta parcha. Okay. So these are the important techniques. And finally, we'll talk about the concept of monoblocks. See, it is always desirable to achieve a complete obturation of the root canal that is not only three-dimensionally complete, but is also uniform in the sense that a single phase of material is present that uniformly fills all the nook and corner of the root canal and seals it three-dimensionally against the fluids. So, depending upon the number of interface, what is an interface? One material, another material. They come into contact. Two different materials are coming in contact. This junction is called interface. One material, another material. So one interface. So depending upon the number of interfaces, three types of monoblocks can be created in obturation of the root canals. The primary monoblock, the secondary monoblock, and the tertiary monoblock. Okay, primary monoblock means there would be just one interface, secondary two interfaces, and tertiary monoblock means there would be three interfaces in the root canal. How do we see it? Suppose this is wall of the root canal and we somehow obturate with a single material. The complete root canal is filled with a single material. There is no distinction into a core and a sealer. Single material is used. So what is happening? There is just one interface between the filling material and the wall of the root canal. This becomes a primary monoblock obturation. Example can be you fill the root canal with empty. Single material, no sealer, no master cone, no core material is there. On the other hand, if this is the wall of the root canal, this is the core material, and this is another material around it. Then there are two interfaces. One is between the core and the surrounding material. Another is between the surrounding material and wall of the root canal. Isn't it? There are two places where two different materials are coming into contact. Example of secondary monoblock. The most commonly used obturation techniques, that is your gatta parcha with sealer. You use your gatta parcha with sealer is an example of secondary monoblock. Isn't it? Or we can say that core plus sealer material, no matter what is the core. It can be a gatta parcha core, it can be a silver point core, it can be a resin based core. If we are using a sealer alongside, then two different materials are there. So first interface and second interface, secondary monoblocks. The third type is a tertiary monoblock, means there would be three interface. So what is happening basically? There is a core material. This core material has got a coating. Okay. And around this coating, there is a sealer material. So there is first interface between the core and the coating on it. The second interface between the coating and the sealer, and the third interface between the sealer and wall of the root canal. So this is an example of tertiary monoblock. Three interfaces are there. So can you think of an example? We use carrier based gatta parcha. Carrier based gatta parcha obturation. Tertiary example, isn't it? This is the central carrier, this is the gatta parcha, this is the sealer. So there would be three interfaces. The tertiary monoblock. These are the different methods of obturation, and these are the different interfaces that can be created: primary, secondary, or tertiary. In a strict sense, this is the true monoblock. Mono means single, so primary monoblock is the true form of monoblock. But what is the disadvantage of using MTA for obturation of the root canal? It is a highly biocompatible material with very good properties, but it becomes rock hard inside the root canals. I have already told you that there should always be a possibility for retreatment of the root canals. If we have obturated the root canal with MTA and there is secondary infection or development of reinfection, what happens? The removal of the MTA is almost impossible, so retreatment would not be feasible. That's why we do not routinely obturate the root canals with MTA. So this is all about the important techniques and aspects of obturation. With this, I am ending today's session. Thank you very much for being connected with me. Happy reading, everyone. We'll see you in the next season. Thank you very much.